So we are going to be working on 7E, and 7E is focusing on being able to apply transformations of graphs of functions. So this is what we've learned already. So we need to understand the rule in terms of if I have reflection in the x-axis, it's meaning that whatever my y value was is going to be having a negative. So the image of y will be negative y. Likewise, when we're doing reflection in the y-axis, that means the image of x will be negative x. So we need to be thinking about it in that form. Another thing I wanted to focus on is this part right here. So if I'm wanting to do it in terms of the graph of y equals f of x maps to, because the y is going to have a negative, well, f of x is that y value. So we're putting a negative out the front. So be mindful of that. Likewise, when we're talking about dilation, the hardest one to remember is when we're talking about the dilation effect of a from the y-axis. From the y-axis, meaning it's affecting the x value. So when we're talking about the image, in terms of the rule, the image of x will be ax. Whereas how we write it is if we're saying the dilation factor, it's x over a. Let's have a go at some of these questions. The first thing that we're going to think about is we've got a transformation that is defined by this rule, x, y, 1/3 x to 2y. So this 1/3 x is the image of x. This 2y is the image of y. So the first thing that we need to do is write it as image of x is 1/3 x, but then we want to get x by itself because our equation has x already. So 1/3 x equals image of x is the same thing as x is equal to 3 the image of x. I'll do the same thing for y. So if we know the image of y is 2y, then y must be the image of y over 2. Now we're just substituting these values into our equation to find the image. So straight away, wherever I see y, I'm putting the image of y over 2. Wherever I see x, I'm putting 3 image of x. I'm then going to simplify. So 3 squared is 9, and 2 times 3 is 6. And then I times everything by 2 to get the image of y by itself. Let's have a look at the next question. A transformation is defined by the rule xy. And we get the image of x is 2x minus 1, and the image of y is y plus 4. So because I've been given the transformation in this form, the first thing I'm going to do is I'm just going to get my y by itself and my x by itself for the image. So we know that our image of x is 2x, take away 1. So then I'll add 1 and divide by 2 to get x by itself. I'll do the same thing with y, but we know that means will be y is equal to the image of y minus 4. We've got our equation, and we're wanting to find our equation of the image. So that means all I'm going to do is substitute the image of y minus 4 into y, and substitute the image of x plus 1 over 2 into x. I will then simplify this. So I will add 4 to both sides. I will then make this as a fraction, so it'll be 5 over 1, which is the same thing as 10 over 2. I've got my denominators the same, so I can simplify this. 1 plus 10 is 11. So that gives me negative a half image of x plus 11 over 2. Now I just realized I made a mistake, so I'm just going to go back and change it slightly. So this negative will apply to everything on top. So that means if I rewrite it, I can take this negative here, and I'll put a negative here and apply a negative here. So then that means I will then have the image of y is equal to negative the image of x over 2. and then that's -1 plus 10 is 9. So it'll be plus 9 over 2. Okay, let's look at this next question. So again, we're going to be doing the same thing. So, but this time our function x squared minus 6x plus 8 is not in the same form. So we need to be able to complete the square. So the first thing we're going to do is we're going to complete the square. That means I'm just going to write down my function. I need to look at b. b is -6, so half of -6 is -3. So I'm adding -3 squared and I'm minusing -3 squared plus 8. This turns into a perfect square of x minus 3, and that leaves me with take away 9 plus 8, and that gives me take away 1 on the outside. Now we're just going to set up our transformation relationship. So first thing, I'm just going to write down my equation and write down my second equation as the image. I'm going to rearrange my equation so everything that's affecting my y is on one side. So that means for this first equation, I will just add 1. And for this second equation, I'm just going to add 10 and then divide by 3. Now I've done that, I'm just going to match up the effects on my y and match up what's happening with my x's. So the first one I'm going to do is just make it as y plus 1 is equal to the image of y plus 10 over 3. And I'm going to match the changes to my x. X minus 3 is equal to the image of x, take away 1. Now I've done this, I'm just going to solve. So I'll start off with my y first. So the first thing I'm going to do when I write it is I'm just going to times both sides by 3. And to get the image of y by itself, because that's what we're wanting to get to, we will just take 10 away and I get 3y take away 7. So that tells me we are, to get the image, we are doing a dilation factor of 3, which is what I've got here from the x-axis, and we are doing a vertical shift down by 7, which is we can see that. The reason why it's 7 and not saying 9 is we need to think about when we put this dilation of 3 in, because we've already got a shift, a vertical shift here. It means that we are applying that dilation to that one as well. So that will turn into -3, which is why it's -7. Likewise, same thing, I'm going to just straight away add 1 with my x to the other side. So that will give me the image is going to be x minus 2. Now, again, if you're unsure what that actually means, if I just quickly draw a small graph, this original graph here, I had it at x minus 3. So that means if I do this, I'm just going to worry about, I'll just put it here. So I had it here at when x is 3, y is -1. Now I'm wanting to move it to be at that one value. So all I'm doing is saying I'm moving it over. So meaning what do I need to do? I need to move it over by 2. Okay, let's look at this next one. Find the sixth of transformation, and that takes our first function to our second function. So being mindful with this, the first thing I want us to think about is that it is, again, not in the standard form. So we need to complete the square. So that means we're looking at what is our b value. Our b value is 4. So what's half of that is 2. So I'm going to be adding and subtracting 2 squared. That gives me a perfect square at the start there of x plus 2. And that gives me -4 plus 1 on the outside. I can simplify that down to -3. And then we're going to set up the transformation relationship here. So that means I'm getting them both of my functions written down, one as y and one as the image. Again, we're going to rearrange our equations. So that means I want to get everything that's affecting my y on my left-hand side. So in the first one, it's just going to be plusing 3 to both sides. On the second one, I'm going to take away 3, and then I've got, this is really divided by 2, so I'll times by 2. So now I've got everything that's affecting my x and everything that's affecting my y um, on separate sides. So if I max the equations, the first equation is just saying y plus 3 is equal to 2 image of y take away 3. With the x's though, it's just got x plus 2 is equal to the image of x plus 2. So there's no changes to my x. It's really the changes to y. So I'm going to simplify this equation. The first thing I'm going to do here is I am just going to divide by 2. So that will give me y plus 3 over 2 is equal to the image of y minus 3. And then I'll add 3. I can simplify this, but I'm just going to leave it in that form for now. And my x stays identical. Okay, slightly different question, but still the same understanding. The points 2, 4, and 4, 16 lie on the graph y equals x squared. They are mapped to 8, 6, and 14, 18, respectively, under a transformation of the form. X, y is going to go to ax plus h, by plus k. Find the values of a, h, b, and k. So just remember what we are doing. This is going to be the image of x, and this is the image of our y. So the first thing that we are going to look at is we are going to create equations using a pre-image and image of the coordinates. So first thing, my first coordinate I'm given is 2 and 4, so that is going to be mapped to 4 and 16. That's the first part I need to do. So the next part that I'm going to do is I'm going to look at that relationship. So I know the image of x is going to be 4. So 4 will equal to ax plus h, and that x value would have been 2. I can do the same thing with my y. I know the image of y is going to be 16, and that y value is 4. So I can make 2 equations based around that. Then it's got, they are mapped to 8, 6 and 14, 18. So I will be doing exactly the same thing. I've written it as the image of x is 14, the image of y is 18, and I will write that as an equation. So now we've done that. This is where we've got our equations with b and k and a and h. So we're going to be using our understanding of solving a simultaneous equation on the CAS. All we need to do is solve it on the CAS using the simultaneous method. I'll do one here. Let's get the CAS up. Okay. So I'll just clear this. You don't need to see all that. Okay, so the first thing we're going to go and do is, if you aren't already, make sure you're on main, go to keyboard, and in keyboard, I'm going to click on this button here in Maths 1. Now I'm just going to put in my equations. So my equations are going to be, I was in the variables, 8a plus h is equal to 14. And then the second equation that I'm going to do is the other one with AH, which is a 2a. So 2a plus h is equal to 8. So I've got my 2 equations in there. What am I solving for? I want to know what a is, and I'm wanting to know what h is. And then that will give me a equals 1 and h is equal to 6. Now we are going to do exactly the same thing for the next equation. So again, I'm going to do exactly the same thing, but this time I've got b and k. So I'm starting off with 4, go to the variables and click on b, plus k is equal to 6. And then down here, I've got 6b. So 6b plus k, I can find it, is equal to 18. Again, on the outside, I'm just putting down the variables that I'm wanting to solve. So I've got b, comma, k, and then enter, and it gives me my two values. So again, I've got for b, I've got b is equal to 6, and k is equal to negative 18. Okay, so let's double check what we just found. So we know that, let's look at the first one. We've got a equals, where is it? A is equal to 1 and h is equal to 6. So that a is not really doing anything. So for this first part, it's really just saying I'm just, whatever my x value was, I'm adding 6. Let's look. If I've got x is 2, I add 6 and I get 8. So straight away, I can see that there is that relationship. If I look at the next one, it said b is 6, so I could write this as 6y plus, and k was negative 18. So then if I look at the 4, it's 4 times 6 equals 24. 24 take away 18 equals 6. So straight away, it works. So it's about double checking your answers.